Today we're going to do section 7.5. So first let's scan the book. Let's see, here is, this page has already been done. So we'll just mostly focus on the new part, which is right here. And that's that. Next, page 240 and 241. Here is the whole page. Let's see, yeah, the bottom one is a bit tilted. Well, anyway, that looks okay. And then a little bit closer on the top. And a little bit closer on the bottom. Okay. Next, page 242 and 43. Let's see, we have, that's the whole page. And then a little bit closer on the top. And a little bit closer on the bottom. Okay. Next, page 244 and 45. This is a long section, so more pages than usual. So this is probably going to be the first, the first part of the video. I doubt I can do it all in one video. Let's see, a little closer. Is it zooming in? I guess it's okay. And then the bottom. Okay. Next, page 246 and 247. Let's see. Okay, so that is the last page of the homework. And okay, so let's zoom in on the top a little bit. Top. Why is that side tilted? Maybe like this. And bottom. Oh, that looks okay. All right, that's mostly just the homework need to be clear. All right. Let's see. So that's okay. Now let's start with section 5. But before I do, I want to explain that I haven't uploaded videos for a week. That's because I went to Disney World on vacation for a week. So and then while I was in Disney World, I did some math. Okay, so I was able to finish the rest of this section, which is like about 20 pages, because I mean the rest of this chapter. But I will talk about Disney World later. Okay, right now let's look at section 5.1. Well, first, before section 5.1 on page 239, we have, normally when we have an integral, we can do a change of variables. That is, for example, if we have the regular integration, if we're integrating from phi a to psi, what is that? I can't, okay, phi a to phi b, okay, right here I'm talking about on page 239. So if we integrate from phi a to phi b of f of x dx, then we can do that trick where we have the change of variable and turn dx into phi prime t dt, and then integrate from a to b instead with various required conditions. So then now we are going to do something similar in multiple integrals. So in multiple integrals, first let's consider in 2 dimensions, where x is represented by g of uv and y is represented by h uv. And now let's assume that this is a one-to-one transformation, so nothing is being folded. 2 points doesn't get to be the same answer. Okay, each one land on its own spot. So each pair of x, y will has its own unique spot in uv, which means if it's one-to-one, that means the relationship also goes backwards. So each uv has its unique x and y if it jumps back. Okay, so everything is everybody has its own own location. Okay, it's like having two homes. Each person has a second home, so they can move to the original, the home. Everybody has a home in one country, and then everybody has a home in a different country. Okay, and nobody has to move into somebody else's house because they don't have a place to live. Everybody's got a place to live in each country, and only one place. Okay, so that nothing's confusing. All right, so then in that case, then we have, let's take an example. Let's say g of u of v is something like v cosine u, h u of v is v sine u. Then, we will bound it into a two. Let's look at the following page. Okay, that is. With that relationship, then we define the two countries like this. This is the XY country, okay, and inside are all the people in there. And then this is the UV country where all the people live in there with their second homes in there, okay. Each person has two homes, exactly, one in each country. So there is and there's a formula to show whose house is where, right? And the formula is given by but first, let's consider the formula for the boundary of the two countries. The boundary of our xy will be called gamma xy, and it will be given as x equal to phi of t, y equal to psi of t, as I'm looking at the bottom of the page here, line 3. Okay, so then, and that is the boundary, and the boundary will be defined from 0 to pi over 2. No reason. We'll define it to some range, right? So that is the boundary, and then similarly, there's a corresponding boundary on the UV country, which we'll call gamma u of v, in such a way that phi of t will be given as g u of v, and psi of t will be given as h u of v. That's because phi of t is x, and as we already said, that x will be given as g u of v, right? So then when phi of t and psi of t are x, then the boundaries will be given in a corresponding way. And these ways are also how we can crank it backwards. If we solve the two simultaneous equations, then we can obtain u and v as functions of t as well, as parametric representation of what the gamma or anything else look like. So having said that, let's turn the page to 240, where we look at the curve that's called x equal to x squared minus 2y plus y squared equal to 0. That is the green thing that I have marked here. Okay, and that curve has a parametric equation. If you work it out, okay, equals to that, and then if you plug this thing into the phi, this is phi of t and this is psi of t into the u and v equations, then you come up with the parametric representation for u and v in terms of t. And specifically, the green part will translate into the green part over there, and by the time you're done plotting. So please do that yourself. Okay, and similarly, the other parts also translate, which the book didn't do, but I did all of it over here. Now notice as illustrated in the green part, in the book, the green part will be transformed through will corresponds to the green part in the UV space, and there's a XY space. Similarly, the red space, that is the horizontal line from 1 to 2, is transformed to the vertical line here. And if you, how do I know this? Well, just work on the transformation. That is, our transformation is defined in this case as x equal to v cosine u, y is v sine u, as given in the book on previous page. So if you solve for u and v, okay, very soon you'll get this, the inverse transformation. This transformation goes from the uv space to the xy space. That is, it takes any value of u and v and then give you the result as x and y. Going back, then if you need to starting at xy, just solve this pair of equations, and very soon you come up with this thing. And I have the details written down here. So, but please do this yourself. Okay, so the inverse transformation is this part, which the book didn't say, but it is. And the book just gave a quick explanation of the parametric transformation, which is fine. but I did this as well, so just so that there is no question. And the book didn't mention that this horizontal, the red line here, the horizontal line transforms into here. Please double check that yourself, okay? And then the purple line here will be transformed to the v secant u over there. If you work at it, as I have done here, you will find out that that is true. So please do that yourself. And then all the endpoints also transform appropriately. That is, it ends up being that this thing is going counterclockwise as t increases from 0 to whatever it's supposed to be, whereas correspondingly, that one goes, this one goes clockwise, that one goes counterclockwise. That is, and if you check it, that is the intersection of purple and red will be, it will get transformed here. The intersection of red and green gets transformed here. So that is, that's why it's going, well, anyway, that please work that bit of detail out yourself. So after you get all the details worked out, then we can, then you need to figure out what the sides are. So for gamma xy, that is the boundary of this, it consists of 3 parts, okay? The purple part, that's a purple, that's the vertical line here, okay? And the red part, which is the red line here, and then the green part, which is the green line here. I guess that's about all I did. I didn't do this part, but it's a similar story, right? You know how to work everything out in parametric or in standard formula or something. Anyway, just work out in your mind how the transformation works exactly. Okay, so you know which side goes where and why. That is for the transformation. It's a bunch of detailed stuff, but detailed algebra. But if you work on it long enough, then you eventually see who goes where and in which direction as t increases. So let's see. Give me a second here. So next, let's consider the second half of the page here, of page 240, where we have, we're going to show this equation 5, to be true. It's a substitution where we're going to plug x and y in terms of u and v in here. So why is equation 5 correct? Well, first, let's figure out remember what g and h are in terms of x and y. G and in the previous page, we have, remember that x is g, okay? And y is h. That's the meaning of all this. So then if we do this, then there is an integration on one side, right? And then there's an integration on the other side. And in our example here, then the clockwise description of gamma corresponds to the counterclockwise description of gamma xy is end up being the counterclockwise description of gamma uv, which is I drew it here as well. And this will be clear once you worked out all the details of the transformation, why that is the case. All right. So then the left of the equation is if we're doing gamma xy, then the integral will be equal to phi. Okay, that phi of integration will be equal to from 0 to whatever number it's supposed to be, and if we plug phi of t in the parametric representation, okay. Now, if we were to calculate the integral of gamma, then it will be from phi of t psi of t. We'll plug x and y, which was phi of t psi of t in the parametric form, right, as we have given in the previous page, where x is phi of t and y is psi of t, but it says t goes from 0 to pi over 2. So anyway, so this one, then if we plug it in, the left-hand side, that is this thing here, would be equal to phi t psi of t and then psi prime of t dt, because we're doing dy here. Okay, so everything plugs in okay. And my only complaint is that the other 0 to 1, which I don't know why, because he said earlier it was 2 pi over 2. It's just a minor detail. It doesn't really affect anything here. But I'm just saying, I think that should be pi over 2. anyway, let's, because the 1, and being that that's what it said before, okay? But maybe the author forgot that he said pi over 2 instead of 1, but it doesn't really matter. But anyway, so the point is we're going to integrate it, and the gamma xy, then we, that is the left-hand side. Now, what about the right-hand side then? The right-hand side is we have all that stuff plugged in. The question is, what is psi of t in terms of in terms of u and v, okay? Now, then we look at the previous page, as we have given the psi of t is given by the equation huv. Now, in that case, then we do the, what is that called? Psi prime of t would be, I can't even remember what this formula is called. But anyway, psi prime of t will be the partial derivative, okay? It will be h1 du plus h2 dv, all right? And so when that is being plugged into the original equation here, then that would make the integral equals to this part. That's where that comes from, and that's why these two equations are equal. Yeah, I also have it written in my notebook. Basically, if we integrate gamma uv q, then g uv is just phi of t, h uv is psi of t, and then this stuff over here is the same as phi prime of t by the, what is that, the chain rule? Is it, well, whatever it's called, okay? We know that this is true. So when you plug it all in, then everything works out. Actually, I'm still tired from my Disney trip, so I'm going to continue this section in the next video.